Objective A. Evaluate a radical expression. Number 1. Square root of 169. Since 169 is a perfect square, I could rewrite the radical 169 as 13 squared. And as we know, square root and square, they're inverse operations, so you could cross them out, and your final answer is simply 13. Since this is already a whole number, we don't need to round it to the nearest thousandth. Number 3, 3 square root of 5. Square root of 5 is not a perfect square, so we need to use a calculator to round it to the nearest thousandths and then multiply by 3. If you do that, we will get approximately 6.708 as our final answer. Objective B. Simplify a radical expression. When we simplify radical expressions, the main goal is to rewrite the radicand as a perfect square multiplied by whatever's left. Number 5. Square root of 49 and then squared. This one, we have inverse operations in the expression, square root and the square. So they cancel out. All we have left is simply 49. Number 7. Square root of 36x to the 6. I always like to break my radicand and put them in different radical signs. We have the numerical part, we have the variable part. I like to break the variable part into separate radical signs as well in terms of different variables. We have numerical part 36, put them in radical sign. We have the radical x to the 6, putting another radical sign. And then you simplify them separately. For 36, I could rewrite that as 6 squared. For x to the 6, since it's an even exponent, I could rewrite that as x cubed and then squared. The whole purpose of doing this is to show you that you could cross out the inverse operations and get your answer rather quickly. So we got 6x to the third. You write that as a product because the original radicand is a product. As a beginner, it's always recommended to show all these steps, but as you become more proficient in simplifying radical expressions, you could skip step number 1, step number 2, and then go straight to the last step. Simplify each expression, factor out any perfect squares. So it's the same idea. Square root of 125, we're going to rewrite that radicand as a perfect square multiplied by whatever's left. So 125, if I rewrite that, it's actually a perfect cube. It's 5 to the third, and this is an odd exponent. For any odd exponent, you could always rewrite that as an even exponent and plus 1. So in this case, 3 is 2 plus 1. Therefore, I will break into 5 squared times 5 to the first. And then I put them in separate radical signs. For the first part, you could cross out the inverse operations, and we obtain 5 radical 5. The second part, the 5 is not a perfect square, so you can't take it out. It stays inside the radical sign. Number 11. Radical 24 divided by 8. Same idea, we're going to simplify the numerical part. Radical 24, I will rewrite that as radical 4 times radical 6. Why do I do that? Is because 24 has a perfect square factor 4. As for the denominator, it's already a whole number, so you don't need to do anything about that. Now let's simplify. Radical 4 is 2, followed by radical 6 over 8. 2 and 8, they have a common factor of 2, so you divide both of them by 2. 2 becomes 1, 8 becomes 4. Write our final answer, radical 6 over 4. Number 13, 2 radical 45x to the 7th. Same idea. Since 2 is outside, you leave it alone. Radical 45, I will rewrite that as radical 9, because 9 is a perfect square, and radical 5. 9 times 5 is 45. For the variable part, it's x to the 7th. I will break 7 into 6 plus 1. So I have radical x to the 6th and radical x. Now let's simplify. 2 is just 2. Radical 9 is 3. Square root of 5 is still square root of 5. Radical x to the 6th, as we did before, x to the 6th is the same as x cubed and then squared. So you simply divide the exponent by 2 and get rid of the radical sign. It's x cubed. Finally, followed by radical x. Because it's not a perfect square, you cannot take it out. And I'm going to reorganize my factors right here. I will put the numbers outside together. Those are the rational part. And then I put the radical parts together as well. So you have 2 times 3, that is 6. And you have x cubed also outside. Inside, we have 5 and x. Put them together as a product. And that is my final answer. Number 15. Square root of 16 over 9. We will distribute the radical sign to the top and the bottom. We will have radical 16 over radical 9. Both of these two numbers are perfect squares. Radical 16 is 4, radical 9 is 3. And 4 over 3 is our final answer. Number 17. Same idea, we will distribute the radical sign. On the top, you have radical 7, radical w, over radical 36. Unfortunately, the only thing that we can simplify at this point is radical 36, which gives you 6. As for the top, none of those two are perfect squares, so we will have radical 7w on the top. Objective C. Solve applied problems involving radical expressions. This question is about the formula, which is the speed s at which water leaves a typical nozzle by using this formula. S equals 12 times radical P. P is the pressure, S is the speed. They want you to find the speed of the water if the pressure is 72 psi, pounds per square inches. So let's plug it in. S equals 12 radical P. And we are given that P is 72, so you plug it in. 12 square root of 72. To simplify square root of 72, I will break it into square root of 36 times square root of 2, because 36 times 2 is 72. And you simplify each of them. 12 times square root of 36 is 6. Square root of 2 is still square root of 2. And that simplifies to 72 square root of 2. And the question did say express your answer both as a simplified radical, which is 72 square root of 2, and as a decimal rounded to the nearest whole number. So if you use your calculator and round it to the nearest whole number, it will be 102 with the unit of feet per second. And that concludes 8.1 odd number solutions. Thanks for watching.